Good evening or afternoon. So we are doing a compound interest. This is a build up from the previous session, whereby we're doing simple interest and discount against each other. Now we are doing compound interest. So what is important when you are doing these is the formulas. How different are they? And also we need to bear in mind, we have to know how to do the calculations. So the learning outcome for the whole chapter, it is you need to be able to master the concepts and applications of compound interest and other interest rate formulae. So there's many of them, like effective interest rate, nominal interest rate, fractional compound interest, and so on and so on. If we've got time, we'll look at those. Compound interest is very important because we are going to be moving with it when we are doing annuities, when we are doing bonds, like throughout the whole chapters. Compound interest is it becomes critical. You don't find much of simple interest. Okay, here are the critical aspects. The critical aspects that we need to focus on when we are doing compound interest. It is actually the definition of the compound interest. And what do we mean about the compounded amount, the present value, the nominal rate, the effective interest rate, the odd periods. The odd periods become very important when we are doing the bonds, the fractional compounding, the continuous compounding, equation of value, and also the comparison between the dates. And what is also important is the timeline. Remember, we said the timelines, they make us be able to understand the story, what is happening. If ever you've got a contextualized story, if you've got your timeline, at least you know if the interest rate has changed in between and what has happened. So we are going to try and get examples whereby we're going to be working with AMA timelines. Okay, so what you have to also bear in mind, what are the common misconceptions or difficulties that have been identified with compound interest? It is an incorrect application of the formula. Maybe it's simple interest or compound interest. It's important that you are extracting the correct formula when you're doing these calculations. Another thing that becomes also a misconception or a difficulty is the substituting an incorrect value. Maybe you are given an accumulated value. Instead of substituting the accumulated value, you are substituting the present value. So it is you need to be very careful when you're doing substitution. Calculations, they are also very important. I'm going to share not for now. I'm going to share. There is a website that you can you can look at when you are doing calculations, especially for this module. It is called Calculator Soup. Just go to Google. Go to Google and just search for Calculator Soup. So this is a website that helps us to, it's got all of the formulas, especially that are related to financial math. So just go and Google Calculator Soup. That's where you'll find the formulas. It calculates everything for you as long as you've got correct components. And what is also important is translating between word problems into mathematical expressions. And another thing that is also a misconception is the compounding periods. What do we mean about the compounding periods? And also the effective interest rate. This is very important when you're talking about effective interest rate, because sometimes you'd be given two interest rates. One is compounding monthly, one is compounding semi-annually. So now you need to be able to compare those two. So we are going to look at some examples on how you can work with the effective interest rate. And we are also bearing in mind the time, how do we interpret time when we are working with compound interest? Okay, so compound interest, it is an interest. Interest is the price paid for the use of borrowed money. I think if someone from sociology, is it social sciences, they can research my slides. How I define compound interest is they will tell that I like to borrow money. I mean, compound interest does not necessarily mean what is an interest that is paid for borrowing money. It can be an interest paid for investing. Okay. Yeah, it's because I mean we are on that other side of the financial system whereby we are the borrowers instead of becoming the investors. It can be the interest that you gain when you have invested some money. And the learning outcomes, it is the explanation. Okay, you need to be able to explain the relationship between compounded. What do we mean about compounded amount? What do we mean by principal? What do we mean about interest rate, and also the term? Those components are very critical, and we need to be able to use the timeline. And calculating these components is also critical, and also applying the correct formula in practical applications. Okay, let us look on on what you'd find even if you go and Google the compound interest formula. Okay, you'll find that the compound interest formula, this will be the basic one that you'd find. Okay, and then, or you can find this one. I prefer this one. I prefer this second one because this second one is giving you the compounding periods, the number of payments. These are the number of payments. I prefer this one. I will take you through a slide whereby I will focus you on the formula that we should be using when we are working with compound interest across. Okay, and then we also have N. Okay, N is the number of times the interest is calculated. Okay, the interest can be compounding monthly, can be compounding weekly, it can be compounding daily. So there are different number of compounding periods, and then these compounding periods have got an impact on the value of N. Okay, so we are going to make sure that we highlight those. So the formula that we start off with, we are starting off with this formula. Okay, we are starting off with this basic formula of the compound interest. If ever you can compare this formula with the one of the simple interest, you see that the simple interest formula, it is S is equal to P into 1 plus IT or RT, does not matter. So those are the two differences. If you look at this one, the formula for the compound interest, it is exponential, whereby your N is an exponent. This one is a simple interest. Okay, I'm doing the comparison. So S here in this formula, it is a future value, and then P is an initial principal. That means it is a present value, and then we are going to redefine N and say N is equal to M multiplied by T, whereby M is the number of compounding periods, compounding annually, compounding monthly, weekly, and so on, and then T is the number of years. Okay, so we are using M multiplied by T because the interest is compounding so many periods. Okay, and then you've got an interest. Remember, we are saying M is the compounding periods. If you've got an interest that is compounding so many periods, you need to take into consideration this notation, and your interest need to be divided by the number of compounding periods. Okay, hence we have this general formula that helps us to talk about the compound interest formula. Okay, and then remember we also have the compound interest. Okay, not the compound interest rate, the compound interest, that is the amount, the compounded amount. The compounded amount, it is I is equal to the future value minus the present value. So we'll be working with these formulas. We'll be working with this formula and we'll be working with these two. Okay, so let us take these and apply them in the calculations. Remember, the first thing that we do when we have these, we always look at these because we want to decontextualize whatever we are given. We want to put everything into a mathematical. We are moving from the word problem into mathematical expressions. Okay, so now you are told here, this is simple. You are told that you must find the compounded amount. Okay, the compounded amount is the amount that you find in the end. The compounded amount on 5,000, that is, this is the amount that you are starting with. So you want how much is going to be compounded. So the compounded amount will be your S, that is your future value. That's what we are looking for. And then this becomes your present value. And then this is invested for 10 years. So the years, the years is equal to 10. And now the interest that is given here, you are given that your interest is equal to 0.075. Okay, and then you are told what this thing is compounded annually. When this thing is compounded annually, our M is equal to 1. Okay, so we know when something is compounded annually, our M is equal to 1. When it's compounded quarterly, our M is 4. When it is compounded monthly, our M is equal to 12. M is equal to 12. If it's compounding semi-annually, that means your interest is compounding semi-annually. Your M is equal to 2. If it's compounding weekly, your M is equal to 52, and so on and so on. So here we are told that this is compounding annually, so our M is 1. So let us use the formula that we said we have promised each other that we are going to use. The formula is saying that your S is equal to P into 1 plus I over M. I want us to use this formula. This is M multiplied by T. You've already decontextualized your story. So your P there, it is equal to 5,000 into 1 plus your interest there, it is 0.075. I am also highlighting the misconception of substitution. And then your M here, your M is equal to 1. And your M is 1 multiplied by your T is equal to 10. Okay, so you can like just plug this thing into your calculator, and then your answer is going to be 10305.16. So now this becomes your compounded amount. Okay, so if the question you'd be asked maybe what is an interest? The interest, remember we said the interest is equal to the accumulated amount minus the present value. So the accumulated amount will be 10305.16 minus your present value of 5,000. So whatever value that you are going to receive there, that becomes your interest, not interest rate, interest. Okay, So let's look on another example. How much interest is earned on 9,000 invested for 5 years at 8% annually? So now here it's just that we are looking for an interest and on something that is earned on something. So this is P. And then invested for 5 years. So your time here is equal to 5 at 8% per annum, compounded annually. Okay, this is similar to the previous example. I'll just break down the components. I'm not going to do the calculation because it is not getting us anything. There's no variation from the previous example. So this thing, our M is equal to 1. Okay. Our M is equal to 1. So I'm not going to do the calculation, guys, because it is similar on the previous example. So I don't see anything that is going to vary your understanding. Let us look on this one. This example is saying now 1,000 is invested. Okay, 1,000 is invested. If your English, like modern graded English, 1,000 is, that is the present tense. Therefore, your P is equal to 1,000 is invested for 1 year. So now your T is equal to 1 at 8% per annum. So your I is equal to 0.08. Be careful on how we are converting 8%, because you can make a mistake and say it's 0.8. So just be careful how you convert to 8% to a decimal number. But the interest is compounding. Okay, the interest is compounding semi-annually. That means every 6 months. How much interest is N? So now we are looking for our interest. How much interest is N? So now we are looking for the interest, guys, here, because we are looking how much interest. So we are looking for our I. Okay, so now semi-annually, that is every 6 months. How many 6 months in a year? You've got 2. So now you've got you are going to your M there. Semi-annually means that your M is equal to 2. Okay, so you can just take your formula. Your formula there is your S is equal to P into 1 plus I over M multiplied by T. So we are looking for I, but according to our information, we know that I is equal to S minus P. So before we can get our I, we still need to find our S. We don't have S, but we do have P. So now let's find the S here. So the P here is equal to 1,000 into 1 plus our interest. It is interest rate is 0.08, and our M is equal to 2, and then you've got 2. You've got 2 multiplied by your T is equal to 1. Okay, so this is equal to 1, and you can just plug this thing into your calculator. So this is going to be 1,000 into 1 plus 0.04 to the power 2, and your answer there is equal to 1081,60. This is not what you were asked. You were asked to find the interest. Okay, so according to this formula, your I is equal to your S, which is 1081.60, minus your P. Your P is there, it is 1,000. So you plug this thing into your calculator. So your interest is 81 Rand 60. Okay, so that is a basic one. It's just that now we want to play around with the compounding periods. Okay, so here 2,000 is present tense. It is modern graded English. So now this becomes your P. Your P is 2,000, is invested at 14%. So your I is equal to 0,14 per annum for 3 years. So your T is equal to 3. Okay. Determine the accrued principal. Okay. Determine your accrued principal if interest is calculated, okay, yearly, half yearly, quarterly, and daily. So remember, what is an accrued? Another name for accrued principal? Accrued principal is an accumulated amount which is similar to your S. Okay, that is an accumulated amount. So now remember, when your interest is calculated yearly, your M is equal to 1. If it's calculated half yearly, so your M is equal to 2. Half yearly, 2 times per year. And then quarterly, we know what our M is going to be equal to 4. Daily, our M is equal to 365. Okay, our formula, we've got our formula here. Our formula, we know that our S is equal to P into 1 plus I over M multiplied by MG. Okay, so our present value does not change. It is 2,000. You've got 2,000 into 1 plus our interest rate is 0,14 divided by our M. For this one, I'm starting with number A. Number A, okay, our M is 1. Okay, this is number A because it's yearly. Our A and your M is 1 multiplied by your T, does not change, it is 3. So when you plug everything into your calculator, you will get that your answer, it is just going to be equal to 2,963,09. And then for B, you are substituting in this formula. So your B, your S is going to be equal to the present value, does not change, into 1 plus the interest rate is 0,14. Our M there is 2. Okay, so we are going to have M2 multiplied by 3. Okay, so your answer there, it is just going to be equal to 3,001,46. You can do the same. Let us do quarterly. It's the same thing where there is your M. So your C, your S is going to be equal to 2,000. Okay, into 1 plus 0,14 divided by quarterly is equal to 4 to the power 4 multiplied by 3. Then you will get your answer. In the similar vein for D, you are going to have your S is equal to 2,000 into 1 plus 0,14 divided by 365 to the power 365 times 3 years. Then you'll get an answer. So that this example is just breaking things down into smaller components when you've got different compounding periods. Okay, let us look if there's anything interesting here. Here, what is the present value? You are asked to find your P if the compounded amount, remember the compounded amount, the accrued principal, those are similar names, the future value of this. So now the future value, you are already told that your S, this is your S. So this is the value of your S. So this is your S is invested at 18%. So your I is equal to 0,18 per annum for 5 years. So your time is equal to 5, and the interest is calculated. So when the interest is calculated monthly, we know that our M is equal to 12. Okay, what is our formula? Our formula, it is S is equal to P into 1 plus I over M to the power MT. We are given our S, so the substitution is important. Read the question so then you don't substitute incorrectly. 1 plus your I is 0,18. Our compounding periods, it is 12 to the power 12 multiplied by T. Our T here, we are told, is equal to 5 years. Okay, so you plug this thing into your calculator. Plugging this thing, you're going to have your P. You can just first rearrange and say this is going to be 10,000. Okay, 10,000. Where is my calculator? I don't have a calculator. But in any event, this is going to be 1 plus 0,18 over 12 to the power negative 12 multiplied by 5 is 60. So you are making P the subject of the formula here. Remember this principle, the principle which is saying, the mathematical principle, the one which is saying if ever you've got your Y is equal to X to the power, I want to write this 2 to the power 3. Okay, so what we do here, we just say our X, okay, our X is equal to Y is equal to 2 to the power 3, negative to the negative exponent. So when we are moving this exponent to your left-hand side, this one becomes a negative exponent. So you are going to have multiplied by 2 to the power 2 to the power negative 3. So that's a concept that I've used here. We are not using the logs, it's just simple exponential manipulation. So your P here is equal to 4,000. You've got 4092,96. Okay, if you plug this thing into your calculator. Okay, let's look what I'm doing here. I am looking on different components of our formula and look at different ways on how we can do calculations, because the way you calculate your future value is different on the way that you'll be calculating your present value, and how you calculate your interest rate is different on how you calculate your time, and so on and so on. So the one way we are calculating time is interesting one, because we need to be able to use the logs. On the previous example, we're using the exponential equations. Okay, so let us look on an example whereby we are confronted by the logs. I know some of us have forgotten how you manipulate the logs. Okay, so now I'll take you through on some basics and take you back on how you do the logs. Here, you are asked after what period of time. You are asked for T. We don't know T. Will 2,000 double? So we are starting off with P. It would have doubled. That means in the future, it would have doubled. That means your S. So now you're going to have 2 multiplied by 2,500. It would have doubled. Okay, so now you start with P, which is 2.5. It would have doubled in a specific time. If the interest is calculated, so the interest is calculated half yearly, which is 0,11, and then it is calculated half yearly, so the compounding period is equal to 2. Okay, so now we need to calculate the time. So now let us get the formula. We always start off with our formula. Our formula is saying S is equal to, let me start from here. Okay, we've got S is equal to P into 1 plus I over M, close the brackets, T. Okay, so our S, it is 2 multiplied by 2.5, which is 5,000. That's your future value. That means the initial amount would have doubled. The double of 2.5, it is 5,000. So the initial amount is 2,500 into 1 plus our interest rate here, it is 0.11. And then we divide it by M, the compounding periods, it is 2. Into our M is 2. We don't know our T. That's what we are looking for. Okay, so we can just simplify everything. Okay, we can simplify everything here. And say 5,000 divided by 2.5. That should be 2. Is that 2? It's 2. So 5,000 divided by 2.5, it is 2. 2 is equal to 1,055. This is 1,055, whatever is inside your brackets, to the power 2t. Okay, so we need to solve for this. This is an exponential equation. So let us get out of here and go and review the exponential equations. Let me get a different pen. Get a different pen. Okay, so remember the exponential equation. The exponential equation, if you've got y is equal to a to the power x, okay, and your aim, you want to solve for x, okay, you want to solve for this x, okay, and this is an exponential. So this is what we see here. We've got our y here is equal to a to the power x. That's what you see here. That's what you see. And we want to solve for 2t. Okay, so now using the logs. So we are going to be using the logs here. Applying the logs are saying for you to solve for x, your x is equal to, your x is going to be equal to, remember the a from the basic mathematics, a is the base. So now to use the logs, transferring between exponents to the logs, your x is equal to the log of the base of a and whatever you find on the other side, which is y. Okay, so now this is the concept that we are going to be applying here. Okay, some people like to use a natural log. You can use natural log. You can use this log, the logarithmics. So now to solve here, you are going to say, using this, your 2t, your tt is going to be equal to log, okay, log of the base of 1,055, no, 0.55, and whatever you find there. Then you still have a problem, okay? You still have a problem because you have a base here. This is the base of 1,055, and your calculator cannot handle. So now we go back to our basic mathematics, okay? going back to our basic mathematics, we are saying we do have our x there, but now if the base is not equal to 10, our calculator cannot handle the base that is not equal to 10. So we are going to apply a principle of changing the base to 10. So to change the base to 10, you are going to have this, apply this principle, you are going to have log y over log a. This is a principle of changing the base. Okay, so now once you are here, you can always come back here in your, you come back to this example. I'm going to box it here. So here you're going to have your 2t. Your tt is going to be equal to log 2. Hello?
Hello. Sorry, I'm a bit lost. So the second last step, you say it's t, and then it's equal to 1.055, and then exponent to 2t. And then the last step, you say to 2t, we put it on the other side, on the left side. And then there was log 1.055. So what happened to the other two, the one that is on top, on the left-hand side?
Yeah.
Oh, so we just bring it back. Oh. Okay.
Look here what we have done. Can you follow me here on this step? Can you see here?
Okay. Yes, I can
so
see
here
now.
You've got this, but now mathematically, if you don't have a base of 10, your calculator will not handle it. Ne?
Okay.
So if ever you are moving from here, ne, your exponent is 2t, okay? So now you take your exponent, you make it the subject of the formula, which is your x, if you compare it here. So there is your 2t, log of whatever base was. So you put the base and then you bring in this 2 here. Is that clear?
Yes.
Okay. So you change the base. This is going to be a log of 1,055. Now your calculator can handle this. Okay. So your calculator can handle it. You can plug this thing into your calculator as a fraction, log 2 divided by log of 1,055, and then your t. And then after you got that answer, you divide it by 2. So your t becomes 6,47. So you take your calculator, ne? Take your calculator, and then you okay. Let me go to my calculator. So our calculator, we are saying if you've got a calculator like mine, you go here on your numerator. You are going to have log of 2. You close the brackets, and then you go to your denominator. Your denominator is going to be log of 1,055. 1,055, and then you close, and then you are going to get an answer, which is 12,94. Yeah. Then let me just let me come here. This is 2t is equal to 12,94. Wait. 12,946. Okay, and then you divide both sides by 2. So your t is just going to be equal to, you divide this by 2, it's just going to be equal to 6,47. Okay, that is the time that you are looking for. Okay, so let us use the one of a natural log. The natural log, you've got your y. Okay, let me get a different pen. The natural log, your natural log, you would have y is equal to e to the power x. Okay, so for you to solve for the natural log, you're going to have your x is going to be equal to ln y, okay, over Lin, is it Lin E? I think it's Lin E, if I'm correct. Lin E, let me just remember the natural log. Let me just remember this log of 2. So you're going to have log of this one divided by this log. Why am I making a mistake here? Okay, let me see. How is the lin is going to work out? Okay, if you are looking for the lin, there is your lin. You've got lin of our y there. Our y here is equal to 2. Okay, ln 2, you close the brackets, divided by, divided by ln of whatever the base that we have, divided by the ln of this base, whatever base that we have here. Okay, so if you're looking at for the natural log, so this is going to be ln of 1,055. You close the brackets, okay, and then you equate, get your equal sign. You go back to this answer, you get the same answer, 12,964, and then you take that amount. You take that amount and then you divide it by U2. Okay, this you divide it by U2. So now every time you've got a situation like this, let me get another example. Let's say you've got let me get a different pen. Let's say you've got 3 is equal to 1,05 to the power, let's say x. I just want to use simple basic variables. So to solve for your x, you're going to have your x is equal to ln 3, and then you divide by ln 1,05. So that is the straightforward with your log. It is also similar with this one. Even here, you can move and say your x here, your x is equal to ln whatever you find on your log, even if you're using logs, log of, and then your log of whatever base that you had of log of a. So you can simply move from here straight to this step. Okay, so this is a mathematical way. So it's either you're using the ln or the log, you are still going to get the same number. It is just the notation that you need to just worry about. I know that your text is using the ln. The ln is for the natural log, but you end up getting the same answer. Okay, and then let's look at another example. Whew, this one is a little bit interesting. This one is a question whereby the periods are dividing. Okay, so we need to be able to decontextualize this and read it and put it into the timeline, because it is not just a straightforward question. Okay, so here you've got Miriam buying a painting for 15,000. She's buying it when? Now. Okay, so for 10 years, the value of the painting increased yearly, okay, by 20%. Okay, thereafter, the value increased yearly by 15%. The amount of money that Miriam can expect to receive if she sells the painting after owning it for 23 years equal to. So here we are looking for the accumulated amount, the future value. Okay, so we need to write this story down into a timeline before even deciding on what is the nature of this or of this story. So now let us write this thing into the timeline. So this is where timelines are critical. Timelines are helping us to understand when there's too much going on. Miriam brought a paint, okay? So there she goes, she buys a painting, okay? Which is, you've got the P there, and then that P is equal to 15,000. That's an amount that she start off with, okay? So for 10 years, the value has increased yearly by 20%. So this painting, she's got it for 10 years, okay? Until here, okay? This is 10 years, so the T here is equal to 10. The painting increases, increased yearly, so you've got 0, 20. Then after 20 years, something happens to the painting. It accumulates a value for 10 years. So here, the thing will accumulate. Definitely is going to accumulate. Okay. So now, thereafter, something happens again. It does not only stop here. Thereafter, the value increased yearly by 15%. Okay. So now when there are many things that are happening, maybe the interest is increasing so many times within an investment period, you need to take that into consideration. So now what we are going to say is you are starting off with a specific present value. For 10 years, this thing accumulates, but we don't know how much it accumulates. Okay, that is your future value. Okay, and then this, when it's going to start again, the amount of money that they can receive the painting after owning it for 23 years. Okay, so now if this thing accumulates, it has to run for another period. Okay, it has to run for another period. Why? Because for this whole period, this thing is equal to 10. This is what it's saying. Your T here is 23 years. So Miriam has owned this painting for 23 years. Okay. However, the interest rate has increased twice. It has increased for 10 years, and then there was another amount. The minute there's a breakdown somewhere, you must be able to break down even your calculations. So now it has run for 23 years. So now we want to understand how much is this period? How much is this period? This one. Okay. So now you've got 23, this whole period. It has already, she has already owned it for 10. It means this new period here, the T is going to be equal to 13. Okay, and then in the end, it must accumulate the final. Okay, the final. Yeah. So one can ask, why are you having S1 and why are you having S2? The reason why I'm having those two is because there was a breakdown somewhere and interest rate changed. Okay. The minute there is a breakdown, because this woman had this thing for, she owned this painting for 23 years, but in between for 10 years, the interest rate had to change. So the minute there's a disturbance, you need to also have breakdown of your calculations. Sometimes you can, like, if it was money, you can withdraw money at a specific time. The minute you disturb the investment, if it, within its period that it has not ended, you need to break down your calculations. Hence, I've got S1 and also I've got S2. And then we are saying at S1, the painting would have accumulated a specific value. Okay. And now when she's starting again at year 11, she's going to be starting with a new present value. So the S1 here is going to be the present value, the second present value that we don't know. So now she's going to be starting this period until S2 with a new present value, which is similar to S1. Okay, so the present value here, your P2 is going to be equal to your S1. Okay, This is going to be your S1. You will see more of these when we are doing annuities, nama bonds, where there's a breakdown of the periods. So I want to throw a question to you. What kind of an investment is this? Is this a simple interest? Is this a compound interest investment, or is it a discount, a simple discount investment? Because this thing is not specifically explicitly telling us what kind of an investment is, but what are the keywords that guides us on what formula should we use? I'm going to throw that question to you guys to help us identify whether we are going to use simple interest formula or the compound interest formula or the simple discount, and why. Why are we supposed to use a specific formula in this one? What is guiding us? And I'm going to wait for your responses. What formula should we use here between these three that I've just...
Compound interest.
Karin?
Compound interest.
Why compound interest?
I didn't expect a why question, but isn't it compounding?
Actually, my interest is at why.
Okay. So the overall amount she can expect after 23 years, it's a compounded amount from the 15 to the whatever the S would be after 23 years.
Mm.
I
No. So because it is increasing, you are talking about S2 as compounded.
So okay, at S1.
Yeah.
The future value at S1, it's an accrued amount from year one.
15,000.
From the principal, yes.
Mm.
And then when you go to S2, it's interest on top of the initial interest. So it's the 15% on top of the 20%.
But I can have a simple interest. I can have a simple interest for the 10 years and then get the money. Okay, in a painting are not working for me. I cannot imagine a painting because most of us do not even think of buying a painting. Buying a painting for that amount, it is just out of context for some of us. So let's go out of the context of Ilentoma paintings. Let's look at money. Okay, you can get into a simple interest investment. Ni batale interest at 20%, then at the end of 10% in Tolimal. At the end of 10 years. That was simple interest. Then I take the very same amount and I invest it again with simple interest again and get another a new accumulated amount. Okay, so your reasoning, you are correct, but now the reason part.
Okay, my question is then a simple explanation of compounding. It's interest calculated on top of interest. Is that correct? So
it is an interest that is
you have two interests, and what you've stated now is if you reinvest on top of the interest you've accumulated over the initial period, does not look like it's compounding. Explain that, please.
The thing, the compound interest, it is when your interest is, we're talking about interest only here, is when your interest is compounding so many times. Okay, so with simple interest, I can have an amount the first period. Okay, I can have an amount. Okay, with the story, it's clear your answer is justifiable with my timeline. Okay, not all of us were in the context of being able to know how to break this thing down into a timeline. If you are just reading this thing without putting it in a timeline, you would find it very difficult to decide, because it could have been the first year, the first 10 years, and then the investment also proceed for another period. It can happen with simple interest, but with this timeline, it is easy to see that you've got S1, and then you take this S1, which has got an interest included, and then you are including another interest. Yes, it is a compound interest because it has been put into a timeline. But the simple explanation, without even putting it into a timeline, this thing which is saying increased yearly, okay, the keyword increased yearly, okay, this thing of saying increased yearly, it's giving a keyword that this thing is compounding. It's more like saying this thing is compounding yearly, which means our M is equal to 1. Okay, our M is equal to 1. Okay, so that is a simplest definition, because it is helping us to get out of the English context into a mathematical context, because we need to know how many compounding periods. For the fact that we are saying increased, it's like compounding yearly. So we know that it's a compound interest because this thing is increased yearly. So you can tell that it's compound interest without drawing a timeline. But once you've got a timeline, yes, your answer is justifiable, because you can see that at S1, I've got something, and then I'm proceeding again. Okay, so yes, it is a compound interest, and it's compounding annually. Where do you see that? You are told that this thing is increased yearly. This thing is increased yearly. This is increased yearly, that it is compounding yearly. Okay, so this is a compound interest. So we are going to be getting 2 formulas, okay? We still need to first calculate the S1, okay? So now let us calculate the S1. So our S1 is equal to P1. I'm starting with this period, guys, the first period of 10 years, okay? Let me use a different color, so then we can be able to break these calculations down. Let me get this. Okay, so now we are saying that our S1 is equal to P1 into 1 plus I. Okay, this is going to be your I1, everything here for the 10 years. And then our M is the same because it is compounding yearly. Bear in mind, sometimes it can be saying in quarterly, but here the M is similar. It could have changed and increased quarterly. So our M is the same, and then this is going to be equal to M T1. This is our T1. Our T1 is equal to 10. Okay, so our P1 is given that it is 15,000 into 1 plus, what is your I there? Your I there is 0.20. This thing is increasing yearly. That means your M is compounding once. So you're going to have 1 to the power. Your M there is 1 multiplied by your T. Your T is 10. I am still calculating for these guys, for this part. Okay, so your S1 is going to be equal to, your S1 is going to be equal to 92876.05. So this is our S1, okay? From our timeline, we know that our S1 is the same as your new present value as you are starting another period, another investment for 13 years. Okay, so now you said, okay, let me get a different one here. Okay, so now let us come and say, now we are moving with the P1. We want to calculate for this period only. Okay, so we are going to say what is the final accumulated value at the end? You're going to have your S2. You're going to have your S2 is equal to, in this case, if you're starting from here, you are starting with your P2 into 1 plus your I. Okay, you've got your I here. During this period, you are told that this thing has increased yearly by 15%. So now your I2 is equal to 0.15. Okay, so you're going to have your I2 divided by your M. Your M is similar, so you're going to have your M, and then you've got your MT2. Okay, so your S2, that is your final value, is going to be your P2. Remember, your P2 is what you are starting with here, okay, which is 92876.05 into 1 plus your I. Your I here is 0.15 divided by remember, what is our M? We said our M is similar everywhere. So this is the same M. So the M is equal to 1. So you're going to have 1 multiplied by your T2. This is your T2 is equal to 13. Okay. So you plug in your calculator, and then your answer is going to be equal to 571 446. This is your S2, your S2, 446.59. Okay, so what is the question saying here? The question is saying the amount of money that Miriam can expect to receive if she sells the painting after owning it for 23 years. What is the amount that Miriam is expecting to receive? I would like to get some from the choices that we have there. What will be the answer? That is the question to you guys. Good. What is the correct answer there? What is our correct answer?
Option 3.
Option 3. What if I would go, just for argument's sake, and put 664 3 2 2, 64. Okay, so I'm putting number 6. How you get 64 is when you have added S1 and S2, it gives you this amount. Will I be correct if I choose option 6? And if I am correct, why am I correct? Because now you've got this one, S1, and then you've got S2. Why don't you add those two? So then I can get this one and only take S2, which is already here, 571. Will I be wrong if ever I said it was 664?
Repeat. So how did you get to 664?
I've added S1 and S2.
On my view, I think you may be
but
wrong.
you have already
added it. We have already added it S1 already, which it was P2.
Yes, you used the S1 answer when you calculated S2.
Okay. I'm raising this question because I'm trying to create what we call in maths education a cognitive conflict. When you are having your little discussions, you must be able to engage with an incorrect answer, because the incorrect answer does not mean you are empty. It means you are thinking. So that thinking is because it's got misconception, and the misconception is the best way of learning. So yes, you are correct that the answer, it is number 3. Why it is number 3? You cannot add S1 and say S1 plus S2 because you're looking for accumulated amounts. It's because S1, when you started the new period, that means for 13 years, you were starting with a new present value. It was your present value. So you've already included it. So whatever that you're going to end up with at S2, it is your final amount at for all the years 23. So I've raised this, it's called a non-example. Non-example is an incorrect example. So then to help you to have that conflict in your mind and question why. Because remember, not all of us are on the same page. Some of us are thinking the other way. So that was a reason why I've asked that question. So the final answer is whatever you're going to find at S2, because you have already included S1 because your S1 was your P2. Okay, you are getting into a circular argument if you are going to be adding S1 and S2. That's a circular argument. You are overinflating the numbers. Okay, which is a circular argument. Okay, let us look on another one. Okay, so here we've got this question. Let's say Lulu deposits 900 into a savings account, earning 6.5% interest per year, compounding quarterly. This one is straightforward. We are told that it is compounding quarterly. We are happy. We know our M is equal to 4, and we are going to be using compound interest. After 3.5 years, she withdraws 1,000 from the account. Yeah. So now the account is continuing, but after 3 years, she decides, I want some money from that account. So now there's been some kind of a disturbance into the investment. Okay. And then she deposits it into another account, paying 11% interest per year, compounded semi-annually. How much is the total accrued amount from both accounts 2 years after making the second deposit? Okay, so there are 2 accounts here. Lulu deposits imali 900 kwi Nedbank. Okay, then after 3.5 years, we have decided, hey, I want some money. She withdraws some money, and she does not withdraw everything. Okay, there could have been some amount that is left, which continues for 2 years, and then we are a Capitec and go and open another account which runs for 2 years. So now we need timelines. Okay, we need timelines for a Nedbank. Let us start with what is happening at Nedbank. I'm going to write here Nedbank. Okay, a Nedbank, this is an account that she starts with. Okay, a Nedbank, Ululu depositor. She goes and deposits. Ne? She deposits she deposits amount, okay, which is equal to 900. Okay, I'm saying 9,000. And then it's this account is got an interest of 0.065, and then it is compounded quarterly. It is compounding quarterly. This is quarterly, and then it is running. We decided with this step after 3 years, so we are going to stop at 3.5 years. So 3.5 years, and we decide to yeah, it continues, and then this thing is for 3.5 years. Okay, this is 3.5 years. Okay, 3.5 years. So now we've got our 3.5. This is T is equal to 3.5. And then we have decided, I want money here. I want to take out 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000. 1,000 and take it to Capitec. This siyahamba se Capitec. Okay, so now obviously by the end of 3.5 years, this thing would have accumulated to some amount that we don't know. Ne? It would have accumulated to some amount. So whatever amount ezobe accumulated ngale 3.5 years, uzothatha lo S lo le amount lena athathe 1,000 yakhe. Uyayithatha uyayiminasa, but there is still going to be an amount that is going to be left in this account. Asiyazi ukuthi malini. Whatever amount which is going to be what is left here. And then uzochubekeka nayo, and then it becomes her final. It becomes her final it becomes if in this account as a net bank. Okay, so now she's going to have S2 la a net bank. Okay, so we don't know what is going to be S2, so this becomes the P2 as we say. This becomes the S1, the accumulated amount. Okay, so this is what is happening in net bank. Now she goes and says, okay, I want in a bank. It looks like I want to buy a tanda. Nami, I want to have some money. Maybe the interest is on the interest right or whatever. There are many reasons that we want to change. Yeah? So she goes to a Capitec. Okay. What is happening here? This thing runs from here. It continues for 2 years. So this continues for 2 years. So this is 2 is equal to 2. Okay. So now she is taking this amount here, 1,000 from this period. Ne? This runs for 2 years. This is 2 is equal to 2. Okay. So she's going to start off a Capitec. Okay. So the present value of Capitec is the 1,000. I'm going to put it as the star. This is for Capitec. This is the present value, which runs for 2 years, and then it's going to have the accumulated amount. I'm going to put a star. This is for Capitec. This is Capitec. The question here to it, sifuna ukwazi ukuthi how much has been accrued from both accounts. Sifuna ukwazi ukuthi imalini as-net bank at the end of the period. Sifuna ukwazi ukuthi imalini as-lento. So we want to know what is S2. What is a star, that is imali as a Capitec. Then we are going to combine those total amounts. Okay, so now we need to find out what kwenzakalani in net bank. Okay, let us go in net bank. Net bank, there are 2 things that are happening. Okay, there's amount that has been withdrawn, and then that amount continues for 2 years. So now let us get in net bank first for this 3.5 period. So in net bank, we are going to be having now S1. S1 is going to be equal to P, okay? Let me say it's P1. It's going to be equal to P1 into 1 plus, okay, I1, which is this one. And then M, let's see what is happening here. Lapa A, lento, lapa A Capitec. A Capitec, the interest is equal to 0.11, and then it is compounding semi-annually. So the M is equal to 2. So our conditions, all our banks are different. Okay. So now a net bank condition is M. Compounding period is 4. Is quarterly. So now this is going to be equal to M to the power MT1. Okay, so net bank, I'm using my pens to show the difference. So now S1, we've got P1 900. So you are going to have 900 into 1 plus the first interest rate. It is 0.065 divided by account as a net bank is compounding quarterly. Okay. So you're going to have 4, and then this period is running for 3.5. So this is going to be equal to 3.5. Okay. So now the amount is accumulating to 11,1127. Okay, 11,1127,85. Okay, that's an amount here. Okay, but uthi yena after this 3,5 ufuna ukuthatha 1,000. Okay, so now to get 1,000 uthi okay, 1,000, that means from this accumulated amount 1127,85 she takes out 1,000. Okay, so now it means the amount that is going to be left there is going to be equal to 127,85. Okay, so now that is an amount that she is going to why is always women who are depositing and have paintings here? Okay, this is an amount as of SLNI and Nedbank. Okay, so this amount still needs to run for 2 years. Okay, so then to get good, okay, how much is going to be at Nedbank? Okay, so now let us take this amount and get the accumulated amount. Nedbank askagayi Capitec bakwethu. So now we go and say the S2 still at Nedbank, the S2 is going to be equal to P2 into 1 plus I. The interest rate as a Nedbank I change isafana. So now we are going to have I1 over M to the power M, but the time has changed. The time we are calculating for only 2 years for this period. So now your MT2 still at Nedbank. We are still working with Nedbank. So now your P2, that's a new amount you are left with, which is 127,85 into 1 plus the interest. I mean, there's nowhere whereby they are saying the interest has changed at Nedbank. So we're assuming the interest rate is still the same. So we are going to have 0,065, and nothing is said about changing of the compounding period at Nedbank. So we are still having 4 to the power. Our M there, our M is still 4, but it is only running for 2 years. So this is going to be multiplied by 2. Okay, this is going to be multiplied by 2. This is going to be multiplied by 2. So the accumulated amount in a bank, it is only 145, 44. Okay, that's it. Still dealing in net bank. So let's see who a Capitec. Okay. Now we go and calculate if he accumulated amount a Capitec. Because he wants to net bank with this 1,000. Okay, she goes to Nedbank, and Nedbank has got different conditions. In Nedbank, it's got an interest that is 11%, and then it is compounding semi-annually, which is 2. Okay, that's what is happening at Capitec. So now I'm going to look what is happening at Capitec. We are saying now the S star as a Capitec is equal to, okay, the P star of Capitec into 1 plus, we've got an interest as a Capitec, and then it's compounding with its own period, and then we're going to have M. Our T is 2 years because Capitec get you into Guti from both accounts after making the second deposit. How much is it from both accounts after making 2 years? 9 for 2 years. Okay. So now we are going to be having that. So now we are saying now our S star is equal to the amount that was withdrawn from a Nedbank, which is 1,000 into 1. I-Capitec in ama rates are different bakwethu. So ama rates akona it is 0,11. 0,11, and then our conditions at this thing is it is compounding semi-annually, which is 2. And then this thing, your M is 2, and then it's multiplied by, it is compounding semi-annually. So now you are going to be multiplying it by 2 because it's for 2 years. So now your S star is going to be 1, 2, 3, 8, 83.
So
Yeah.
in the three different timelines, is the answer the sum of P2 plus the second 145 plus the third 1238?
What are the amounts there? 1238. Okay. So can you please you are saying the total amount is what?
Is it the 1127.85 plus 145.44 plus 1238?
Okay. No, your final answer, remember, if ever we can go back to the previous question whereby we said, if you've got one investment and then it gets disturbed somewhere, your final amount is the final amount of the investment is whatever you are ending up with. That is your S2. At Nedbank, your accumulated amount that you find is S2 because the 1127 you've already taken it into consideration, and then you subtracted you subtracted you subtracted the 1000, then you had UP2 which was 127, and then you took that amount and invested it further for 2 years. Then you had a final amount in that account. If you go and get the balance, your statement is going to read 145 in Nedbank. Then a Capitec, your final amount, it is 1238. That's what is going to be reflecting on your bank statement. So now your total amounts that you are going to find on two of these banks, it is the two amounts, 1238 and 145.44. Is that clear? Is it making sense?
Yes, it
or you want to take it? Yeah.
No.
I think you know what is happening. You remember when I said I was making a cognitive conflict? I wanted you to see if ever you've got one investment and then there's a disturbance in between, the final amount must not include the previous accumulated amount because you've already taken it into consideration. So we are saying now your total amount that they are looking for from these two amounts, it is the amount that we've accumulated Capitec. Remember, this is our Capitec, and also the amount that we have accumulated and here Nedbank. So you're going to be adding these two amounts. Okay, once you add these two amounts, you'll find that the total amount is going to be number 3. Okay, so now try and play around with the timelines, because the gist of everything is how to interpret the timelines. But if you write the story, the timeline, it makes your life easy.
I have a question.
Yebo.
Based on this example, so for let's say the first it's the Nedbank. Nedbank has more compounding periods.
Yeah.
Than Capitec.
So
if she had left her money in Nedbank, it would have compounded more than the total amount that she gets that option.
How much would it be?
No, I'm asking you a question. Would the amount have compounded more because of the quarterly?
We would have to check, because that means what you are saying is, let's say you started off ngo 900, ne? Okay, she started off with 900, and then the investment, the total period of the investment, it is 5.5. Do you agree with that?
Yes.
You agree with that?
Yeah.
Ne? So now it means now we have to calculate had she left her money in a bank with the same compounding period, with the same interest rate, how much she would have in a bank. Then compare it with the Capitec. But now, remember now, you are comparing an apple against a banana. A Capitec, she's only have interest rate is different. It's more, but it is different and it's only for 2 years. We understand? What the chances are, I don't know how much she would have got, but the chances are, because the amount that she took out of Nedbank, it was 1,000, which made Imaliasa Nedbank it becomes little. So now what we would have to do is to check how much she would have got in Nedbank had she not taken 1,000. Okay, so now that will be a calculation that you can quickly do for us on the side, so then we can see how much was it, what was an accumulated amount, and then we compare a Nedbank with a Nedbank for 2 years, but it was not going to make sense because now we are comparing an apple against a banana. A Capitec is only for 2 years. Yeah, so
okay, thanks.
That will be, yeah. We need to be careful when you have to do that comparison and advise our clients to say the Capitec is only rent for 2 years and you're comparing it for something that has rent for 5.5 years. Okay, unless you are saying Capitec has started the same period as the one of Nedbank. Yeah. So let's move on. What is this? Richard needs a trip. What was this question about? I don't know what was this question about. It's about the logs. Okay, I'm not going to spend time on this question, guys, because I've already attended to the question of calculating the times. I'll just break this thing and decontextualize it because I just want to quickly go through our effective interest rate, Naboma, on how you convert an annual, a nominal to nominal interest rate. So I'm just going to break down this thing into different components. This guy needs this amount, okay, for an overseas trip. You need that for a future trip. Ne? How long will it take for him to save towards this amount? Okay, if he deposits, so this is a deposit, that is your present value. So your present value is 25,000. He needs, this is the amount that he needs for the future trip. So that is a future value. Comma 42. How long will it take? We are looking for UT. We don't know how long it's going to take into a savings account earning this interest. So now your interest is equal to 0.105, which is compounding weekly. Compounding weekly, your M is equal to 52. Okay, you've got 52 there. So now what you do, you just need your formula. You plug in everything into your formula. Okay, guys, what you need to do here is to plug this thing into your formula, and then you use the logs. Okay, I'm not really going to go through that because I really want to attend to the effective nominal and effective interest rate.
My question is what does nominal mean? Because in different modes, it's used differently.
So in nominal interest rate is what is quoted compound interest rate on an investment loan, like the one that we were doing. Okay, the one that we're doing, the previous questions, that is a nominal interest rate. That is what will be quoted when you are getting your loan, and then you are told, good, this thing is going to be, the interest rate here is going to be 5% compounding annually. That is your nominal interest rate. Okay, so it's what we've been working with. We've been working with nominal interest rate. Okay, so there are different compounding periods as we've been doing. So that's what we've been sensitized to. And now what is the difference between these? And okay, this is an example that I thought I was going to do, but I'm not going to do. Okay, now the effective interest rate of a loan is equal to the interest rate of a loan that compounds yearly and pays the same amount of interest. Effective interest rate, ne? Okay, angithi sithe nominal interest rate on the previous slide. Nominal interest rate will be what is quoted. It can be quoted like a quarterly and say, okay, the interest rate of 5% compounding quarterly. That is a nominal interest rate. But when you want to convert that quarterly to become an annual effective interest rate, so the new rate that you are going to get is called effective interest rate. So effective interest rate is an annual rate of whatever nominal rate that has been quoted. I hope I'm making sense. If you are quoted a monthly nominal interest rate of so much, you want to get an equivalent amount, which is an annual rate. So that equivalent amount, equivalent percentage, which is calculated annually, is an effective interest rate. So that's why that is the difference between the two. Okay. So what we were doing, we've been calculating effective interest rate in the formulas, but we were not explicit. Okay, we took the given the quoted interest rate that was compounded so many times, but we did some calculations. We divided by the compounding periods to make it an effective interest rate to become annual. So that is a difference between the two. Okay, so here is the formula for an effective interest rate. Okay, don't worry. Hello?
Lizeka, please repeat this. I am missing it. You are saying effective rate is an annualized nominal rate?
Yeah.
So that's what, divided by 12 or 365? What exactly does that mean?
This is how you convert. You convert according to the compounding periods. Okay? Look at this formula. Can you see the formula?
Yes, go ahead.
Okay. Look at the formula. The formula is saying that JM, that little JM is a nominal rate that you are told, Guti, this nominal rate, it is 5% compounding quarterly. That is a nominal interest rate. But you want to convert it to become annual. You are annualizing it. To annualize it, you divide it by that given, that quoted compounding period. We understand?
Yes, yes.
So if ever you are quoted a nominal interest rate that is compounding quarterly, that means you are going to divide your interest rate, the one that is quoted, by 4. If you are quoted a nominal interest rate, a monthly normal interest rate, you are going to take that given interest rate and divide it by 12 to get an annualized equivalent rate of that compounding period. So you get an annualized rate by dividing by the different compounding period as it is quoted to you. You understand? Hence, the interest rate is written in this form. 12 is for monthly compounding periods. 2 is for semi-annually. Weekly is going to be 52. If ever your quoted interest rate, it is compounding daily, you are going to divide that interest by 365 in order for you to get an effective annual rate. Okay, these are just the calculations. This is a continuous, just straightforward. There's nothing interesting about the continuous compounding. The only thing that is interesting is this one. This is very interesting. This is interesting because when we are doing annuities, when we are doing even nama bonds, we will be quoted will be quoted to a nominal rates. Okay, you will be quoted quarterly rate, ne? And your payment period are monthly. Okay, so you want your payment periods to be similar as your interest rate. So you want to convert interest rate yakho ibe similar with your payments. Okay, payment period. So now this is what is happening here. You can convert from one compounding period to another compounding period. That means you can convert from monthly to quarterly by using this formula. Okay, this is not an effective interest rate. It is converting between two nominal interest rate. You can convert from quarterly to daily using this formula.